For more information, please visit SGMAK Associates website.
Let us talk about random variable. Let me start with some examples of random variables related to a manufacturing or a service system. Interarrival time, processing time, quality of output, time between machine failure, and machine repair time. These are some examples. How often part comes to a system, how long it takes to complete a cycle, as you make parts or prepare documents, what's the quality, machine fails from time to time. If you capture the time between failure, that's all. These are examples of random variable. We can represent a random variable either as a discrete or a continuous random variable. This you have to be very clear about this distinction. As you identify a random variable, it has to be either a discrete or a continuous random variable. Now, if a random variable measuring time, volume, mass, or area, if you have one of those situations, you are dealing with a continuous random variable. So, volume of a part made by a manufacturing process, it will have a nominal value, but they'll have a variation because of the process itself. So, the volume of actual part can be treated as a random variable. Anytime you're measuring a time, in the previous slide we talked about time between arrival, time between machine failure. These are all examples of continuous random variable. Discrete random variable is easy to identify. A very simple example that you can relate to is number of parts made over a specified period of time. If you have an automated machine and that can give consistently output, then it becomes a deterministic number. But if you have a cycle time that is affected by variation, then output over a fixed period of time can be treated as a random variable, and it has to be treated as a discrete random variable because you get a discrete number as an output. Number of customers arriving at a fast food restaurant during the lunch hour. If you take a lunch hour 11:30 to 12:30 and watch how many people coming in a local fast food joint, if you collect it over a period of a week, you'll find that there is some variation. Every day will not be the same number. But what you're counting is how many people came in through the door during that 1 hour period. And you'll find that you have to treat that as a discrete random variable. Now, two important concepts dealing with a random variable are probability mass function and the cumulative distribution function. Now, for a discrete random variable, we call it probability mass function. If you're dealing with a continuous random variable, we call it a probability density function. But whether you are dealing with a discrete or continuous, we have a cumulative distribution function. So it's very important to understand the difference between a probability mass function or density function and the cumulative distribution function of a random variable. The cumulative distribution function plays a very important role if you have to generate random variable from a specific distribution. So if you later on take a course in simulation, you'll be using that a lot.
Hi, we are posting materials online. If you have any doubts or any questions regarding the materials posted, feel free to get in touch with us through email. Provide your name, address, school name, your contact information. We also welcome if you provide comments so that things can be improved upon. We also appreciate if you provide any feedback. Okay, so let us know what do you think about the material posted. Okay, bye now.
For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website.